Hi, I'm Seth, and in this video I'm going to talk about central tendency, specifically the mean, median, and mode. Here are some definitions of central tendency that I like. Central tendency is a number that describes the center of the distribution. It represents where scores are most concentrated, or it represents the entire group, so it's a typical score. It could be thought of as a number that conveys the most information about the distribution. It could be thought of as the true value for a variable. If you think of any of the differences, any of the variability in the distribution as representing noise, random noise, then that would make the center, perhaps, the true value. And I put true in scare quotes because that's kind of an abstract theoretical idea. Then, as we start getting into more advanced analyses, we'll start thinking of central tendency as a model. And by that I mean it's modeling the predicted value of the variable. You could think of it like this. If we randomly selected one score from the distribution, what score would be most likely? Hopefully these definitions will become more clear as we go through some examples of central tendency. The first one we're going to cover is the arithmetic mean. You're probably familiar with this one already. It's what most people would think of as the average. Well, in statistics, we call it the arithmetic mean, or you'll often hear people just refer to it as the mean. To calculate the mean, you add up all the parts and divide by the number of parts. So in this contrived data set, where we just have the numbers 1, 2, 3, 4, and 5, if you add those up and divide by 5, you get 3. That is the mean of this distribution. So the calculation's not wildly difficult, but I want to explore two different ways to think about what the mean represents. One way to think about it is as the total divided into equal parts. Another way to think of it is as the balancing point of the distribution. Let's look at these one at a time. If we're thinking of the mean as the total divided into equal parts, you could think of this process as asking, what single value could we use for each number in the dataset so that the total remains the same? With our dataset, we have 1 plus 2 plus 3 plus 4 plus 5. That sums to 15. So the total is 15. If we were to reassign each value to 3, which is the mean, the total would remain the same. 3 plus 3 plus 3 plus 3 plus 3. That sums to 15. In this way, you can think of the mean as taking the total and cutting it into equal parts. Alternatively, or in addition, you could think of the mean as the balancing point of the distribution. The mean is the single value where half the weight of the distribution is below and half the weight of the distribution is above. So if we were to position the distribution on the point of the triangle like this, it's the single value where the distribution would balance. No other point would balance the distribution in this way. So for example, if we tried to set this distribution off to the side like this, what's going to happen? It's going to fall off. That's not going to balance. There's only one point where half the weight is above and half is below. Next measure of central tendency is the median. You can think of the median as the middle value in the distribution, or more precisely, it's the value below which 50% of the distribution lies and above which 50% of the distribution lies. So if the data are continuous, it is the 50th percentile. You can find the position of the median using this formula, n plus 1 divided by 2. In this distribution of 5 scores, that gives us 3. So the median is at the third position. The third position here also happens to be the value 3. So the median is 3. You can see that if you have an odd number of scores, the median is just going to be the middle value once you've lined the scores up from lowest to highest. When you have an even number of scores, the median will be halfway between the two middle scores. In other words, it will be the mean of the two middle scores. The same formula will give us the position of the median, except now it's going to be a fraction or a decimal. Here we have 10 scores, So the position of the median is 5.5, or halfway between the 5th and 6th positions. The 5th and 6th values here are 10 and 11, so the median is the average of those two, which is 10.5. Lastly, we have the mode. The mode is the most frequent score. So in our distribution here, I've changed it a little bit. Now we have 1, 2, 2, 4, and 5. The mode would be 2 because that is the most frequent score. It's also possible to have multiple modes, like in this example, where the most frequent scores are 2 and 5, both of which occurred twice. Now, before I jump into the next section, you'll need to understand data types. I'm not going to go over these in this video, so if you're not familiar with nominal, ordinal, interval, and ratio data, I would suggest pausing to familiarize yourself. Okay, the last thing I'm going to talk about is guidelines for when to use each measure of central tendency. And here they are, but I'm going to go through them one by one. First, if you have nominal data, the only measure of central tendency that will make any sense is the mode. For example, eye color is nominal data. I've assigned a 1 for blue, 2 for brown, 3 for green, and 4 for hazel. So these numbers are really more like names. They're not giving us any sort of order. And you can see that if we did calculate the mean, we would get 2.5, which doesn't really mean anything. This becomes obvious whenever we assign different numbers to represent each eye color. So if we use 10 for blue, 20 for brown, 30 for green, and 40 for hazel, our new mean would be 25. Hopefully you can see that if the value of the mean changes, depending on what numbers we arbitrarily assign, then the mean doesn't actually mean anything in this context. You would also find the same for the median if you give it a try. And that is why we would use the mode in this situation. The two most frequent eye colors are brown and green, both of which occurred 3 times in this data set. Second guideline, for ordinal data, we can use the median or the mode. In this example, I've assigned a 1 to freshman, a 2 to sophomore, 3 to junior, and 4 to senior. These are ordinal data because the numbers represent categories, but they are going in a sort of order where higher numbers represent more years of education completed. Once again, we could calculate the mean, but it would be nonsensical. In this case, the mean would be 2.23, but the mean assumes that all the categories are evenly spaced. It assumes the data is interval or ratio level. And we don't know that's the case. If someone is a sophomore, what does that really mean? Are they in their first semester, their second? How long have they been a sophomore? The fact is that any 2 sophomores, or any 2 freshmen for that matter, have not necessarily completed the same amount of education. So calculating the mean gives a false sense of precision. In this context, we would instead use the median or the mode. Some people will say you should not use the median for ordinal data, but you can because the median is simply defined as the value at which 50% of scores are below and 50% are above. However, in this case, because there are only 4 categories here, I would probably go with the mode. It would probably be easier to interpret and make sense of. And if you're just trying to describe your data set, with so few categories, you're probably just going to report the frequencies of each. You would say, we have 3 freshmen, 5 sophomores, 4 juniors, and 1 senior. Guideline 3, when you have interval or ratio data, you will probably want to use the mean. Because it's the balancing point of the distribution, the mean takes every data point in the distribution into account, which has pros and cons, as we'll see. In contrast, the median and mode only take 1 or a few values into account, which also has pros and cons. But it turns out that the mean allows us to conduct a lot more calculations than the other two, so when we can get away with using the mean, we will. In this case, if you add up all the values and divide by the number of values, you come to 1.45. Guideline 4. even if you have interval or ratio data, if the distribution is skewed or if there are outliers, you're instead going to want to use the median probably, or perhaps the mode. Here I've plotted the number of TikTok videos that students in my statistics class have created in their entire lifetimes. The x-axis represents the number of TikToks made, and the y-axis represents the frequency of students reporting that number of TikToks. This may be a little hard to see, so I'm going to zoom in a minute, but what's happening is most of the scores are piling up near 0 TikToks. That's off on the left. We do have one extreme outlier, which is 25,000 TikToks. It seems a bit high, but I guess that is possible. You can probably already see the effect that that outlier is having on the mean. It's dragging it away from the rest of the scores and out toward the outlier. This happens because the mean involves taking every single data point into account. I'm going to zoom in on the part of the distribution on the left. Okay, so I'm zoomed in and we only see people who reported between 0 and 100 TikToks. So we're not looking at a couple of those outliers off to the right. This is the characteristic pattern that you're going to see with skewed data or with outliers. This is called a floor effect because scores are piling up at 0, which is the lowest possible count you could have. You can see that the mode is 0. That is the most frequent number of TikToks reported. You can see that the median is somewhat dragged over by the skew, and the mean is really dragged by the skew. In fact, in this context, you might think, wow, the mean is not a very good representation of these data at all. If you're thinking of the central tendency as a single score that best represents the data, the mean is not doing it in this case. It's not particularly close to any of the values, and that's because of that extreme outlier. In this case, you would probably want to report the mode and or the median, which I think you'll agree are more representative of the data. The fifth and final guideline is for bimodal or multimodal distributions, which is where scores are sort of piling up and concentrating at multiple locations along the x-axis. When this happens, you're going to want to report the modes, because as you can see, the mean and the median are doing a very poor job of representing these data. There are relatively few scores at the value where the mean and the median lie. In contrast, the mode is doing a very good job of representing where the scores are concentrated. So in this case, you would want to report the two modes. Okay, that is it for central tendency. Hope that was helpful. Let me know if you have any questions.